So I think a lot of people, when they look at the problem like this, they're trying to find the velocity because they mentioned that it's moving at constant speed. We actually don't need to find the velocity because they say it's moving at constant speed. So if we find out the value of mv squared over r, the centripetal force, we can use that in other parts of the problem. So we start here at 3 o'clock and we say the sum of the forces along the radius, right? Which in this case we have mg pointing along the tangent to the circle. Along the radius we only have the tension, and so we can set that equal to mv squared over r, right? And they give us that the tension is 20, so we can use that in other parts of the problem, right? So we're going to remember this, right, that mv squared over r, right, the centripetal force acting on the ball at any point is going to be 20 newtons. And so when we go to the 12 o'clock case, we see that now we have tension and the gravitational force acting along the radius. And so when we do the sum of the forces along the radius, we have the tension plus mg, right? And this is always going to equal, when you're moving in a circular path, equal to mv squared over r. We know that mv squared over r is 20. We know that mg is approximately 15 newtons because of the mass being 0.15 kilograms. And so we get T plus 15 equal to 20. So the tension in the 12 o'clock case is 5 newtons. At the 6 o'clock position, now the center of the circle is up here, right, above the ball. The tension from the stick is pulling up, but now the gravitational force is pushing away from the center, so we'll treat that as a negative quantity. We'll have the sum of the forces. Tension is positive towards the center, minus mg, which is now going away from the center, but this is still equal to the same mv squared over r. And when we plug in our numbers, the same as before, we get T minus 15 is equal to 20, and that is 35 newtons. That's one answer. And so the big key here is understanding that mv squared over r, because it's moving at a constant speed, even though it's in a vertical circle, is always the same value of 20 newtons. And then understanding why at the two positions, in one case mg is going towards the center of the circle, and in another case mg is going away from the center of the circle, and because of that we change the positive and the negative signs of those.